Hi everyone, good evening all. Today I am going to discuss engineering mathematics with first topic mathematics 1 followed by subtopics. So for 2021 GATE batch, so many of you know about that GATE, how many marks, how many questions. Anyhow, this is the first subject, so I am going to discuss a few minutes about GATE, marks, number of questions, how to prepare and remaining etc. So this is for 100 marks. $65 questions. Total number of questions is 65 questions. 10 questions. 5 into 1 mark questions plus 5 into 2 marks questions is equal to 15 marks for numerical aptitude, NA and VA, numerical aptitude, verbal aptitude. Next, engineering mathematics, is minimum 12, maximum 15 marks. It's a rare case, 17, 18 marks. Similarly, lowest 11 marks, it's a rare case. 1 or 2 years asked 11 marks. Similarly, 2 to 3 years asked 17, 18 marks asked. On an average, 12 to 15 marks. Remaining core topics. That is your respective engineering stream topics is $70 to $73 marks. So the first two subjects, that is in this NA, again numerical aptitude is nothing but mathematics, which is from our childhood class, 6th, 7th, 8th, 9th, 10th. So this is 8 marks, and this verbal aptitude English 7 marks. So total engineering mathematics worst case, minimum case 12, 12 plus 8, 20, and maximum case 23. So for the first two subjects, minimum 27, maximum 30 marks. Almost 1/3 of your GATE, 100 marks. Okay. And these two, engineering mathematics, remaining technical topics, core topics, 55 questions. Out of 65 questions, 10 questions for first subject, numerical aptitude and verbal aptitude. In this case, $85 marks, 30 into 1 mark questions, $25 into 1 mark questions, plus 30 into 2, that is 2 marks question 30. This is 60 plus 25, 85 marks. The first subject, aptitude, 15 marks. 85 plus 15, 100 marks. Here, 55 questions plus 10 questions, 65 questions. Okay. So, again that engineering mathematics is divided into two parts, mathematics 1 and mathematics 2. Because of mathematics 2 is not for 1 or 2 streams, example computer science, they have separate mathematics, second mathematics topic name, which is also called discrete mathematics. So that is why the common topics first, mathematics 1, I am going to start now after a few minutes. So let us discuss, I am going to discuss how to prepare and how to write that some exams conducted by our GATE Farm Institute. So everyone definitely crack the GATE exam providing the following requests, the following conditions. Number one, attend the classes without fail. 100% attendance is required till the last class. Second one, attempt the exams. There are that means conducted by our GATE Farm Institute, 3 types of exams. Chapter wise test, sessional test, that full length test which is also called target level test, that is a GATE point of view. Don't bother about exams, marks conducted by our GATE Farm Institute, minus marks, or we have not prepared, why should we write? Please ignore all these things. So you are going to attempt the exam for knowing the questions in different ways. Okay, that is the purpose only, knowledge purpose only. If you prepare seriously, that is useful for automatically the final exam, main exam. Next, third request is, from today onwards, you spend half an hour on engineering mathematics for practicing the class, daily class notes or related GATE questions of remaining streams. What is the meaning of remaining streams? For example, electrical engineering stream. So you first do your GATE questions after the class teacher notes. Then there is a time, 10 minutes, 15 minutes. The related topic of remaining engineering streams. Remaining engineering means electronics and communication, mechanical, civil, because almost 90 to 95% syllabus common is for every stream. From 2016 onwards only, 5% to 10% topics are different. That means some small topics added, deleted from 2016 GATE onwards. Okay. Half an hour on engineering mathematics and half an hour to 45 minutes on NAVA. That is minimum 1 hour, maximum 1 hour 15 minutes on these 2 topics daily, apart from your college works and regular works, etc. Whenever you are having semester end exams or practical exams, in that case ignore that GATE preparation, remaining all days. And sudden declare holidays or college holidays or semester end holidays or some festival holidays, practice. That means you have to spend minimum 8 to 10 hours on core topics, that is remaining engineering stream subjects. Definitely everyone will crack the GATE exam. So these are the 3 following my requests, okay, before to start off engineering mathematics class. So the first part is mathematics 1, which is containing 4 subtopics, which are for all streams except CS stream. For CS stream, having 3 subtopics from 2016 onwards, numerical methods deleted for computer science engineering stream. So all of you, please put the heading mathematics 1. And refer study material also. They provided very much number of questions, explanations for every small topic, subtopic, note point, properties. Many of the questions, fill in the blanks or choice, that is multiple choice questions. So many questions our GATE Farm Institute provided. So first priority class teacher notes, then followed by related GATE questions. The third priority is remaining, if you have the time, study material also. Okay, definitely you will crack the GATE exam. Wish you all good luck. Engineering mathematics, the first topic. In that 2 parts, the first part is mathematics 1, 4 subtopics, that is means chapters. Chapter 1, linear algebra, which is simply called matrices. Number 2, calculus, differential and integral which is mainly from 11th, 12th standard. Number 3, probability and statistics. Number 4, numerical methods. So the fourth subtopic, fourth chapter, except CS tree. So first 3 topics, chapters are common for everyone. Computer science stream has no the chapter numerical methods. Computer science stream having the first 3 chapters only. Remaining all streams having 4 chapters of the topic mathematics 1. So, put the heading, all of you, matrices. So, I am going to discuss first 5 to 10 minutes the basics, that is which we are already studied 3 times, 10th class, 11th class or 12th class, again BTech first year, 3 times that basics. Basics means definitions, that is definition of a matrix, types of matrices, next operations on matrices, etc. Okay. So you know that it is a 2D array. A matrix is the arrangement of elements in lines. Horizontal lines are called rows, vertical lines are called columns. Finally, it is arrangement of elements in rows and columns. Elements are also called entries. Matrices are denoted by upper class letters, capital A, B, C, etc., whose elements are denoted by small letters. So, a general A m cross n matrix is given by, this is the square brackets denoted the symbol for matrix. The suffix m into n or m cross n or m by n. The number of ways can speak or read. M into n, m by n, m cross n, which is called order or dimension or size of a matrix A. The first suffix indicates row, the second one indicates column, that is rows into columns. So M means it has m rows, n means the matrix A has n columns. How to write the elements? The total number of elements in that matrix A is mn. So what is that mn? For example, if I take 2 rows, 3 columns, total number of elements in that matrix is 2 into 3 is equal to 6 elements. Okay? So, A11, which is the first element in any matrix, in a matrix A. First row, first column element. A12, first row, second column element. So on, first row, nth column element. So these are the first row elements. Next, second row, first column element. Second row, second column element. So on, second row, nth column elements. So these are the second row elements. Like that, mth row, first column element. Mth row, second column element. So on, mth row, nth column element. So this is the way to write a general matrix A with m rows and n columns containing mn elements. Okay? Now the types of elements, types of matrices. So when I putting a horizontal arrow indicates 1 by 1 definition or 1 by 1 property or 1 by 1 node point or result, etc. You can put the indices 1, 2, 3 or just by arrows. Okay? m not equal to n, then A is called. A means the above matrix, rectangular matrix. So I am using or writing short form. MAT stands for matrix. So every time writing that is matrix, 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 it is either difficult or continuously writing, time wasting. That is why I am writing short form. Okay. Next, m is equal to n, then such a matrix A is called square matrix. You know, in 2D geometry, rectangle means length not equal to breadth, square means length is equal to breadth. That length is here considered as row, that breadth is here considered as column. Okay. M is equal to 1, then that matrix is called row matrix. N is equal to 1, then A is called column matrix. Okay. So, in this case, example, A is equal to 1, minus 2, 3, 0, minus 1, 0. This is 2 rows, 3 columns, which is a rectangular matrix, simple example. Or you can take 2 cross 4, 3 cross 1, 3 cross 5, anything. Okay. So, in this, A is equal to minus 1, 2, 5, 0, which is a simple 2 cross 2 square matrix. Rows equal to columns. In this, A is equal to 7, 0, minus 1, which is 1 row, 3 columns, which is a row matrix example. In this, A is equal to 1, minus 1, 2, 3, 4 rows into 1 column. This is a column matrix, this is a row matrix, this is a square matrix, this is a rectangular matrix. Okay, simple examples. Next, if all elements are zeros, such a matrix is called zero or null matrix. Otherwise, the matrix A is called non-zero matrix. If all elements are zero, then the matrix is called null or zero matrix, which may be any order, that is square matrix order or rectangular matrix. Non-zero matrix means at least one element is non-zero. So, all these 4 examples are non-zero matrix. At least one element is not equal to 0 or all elements not equal to 0 also. Okay. Next, you know numbers 2 types. Real numbers, imaginary numbers. Every element is a real number. That means be fractions, integers, non-integers, rational numbers, irrational numbers, anything. So all these examples are called real matrices. If at least one element is imaginary, I by 2, minus 3i, 1 plus I, 2 minus 3i, that is either a purely imaginary or complex number. Such matrix is called complex matrix. If all elements are real, numbers, then A is called real matrix. That means every element is a real number. Otherwise, A is called complex matrix. Example, A is equal to 1 plus I, 0, 3, minus 2I, which is a square matrix. One of the element is imaginary. I means imaginary, I value root minus 1, which you will understand clearly in complex numbers, 11th standard. I is equal to square root minus 1. Okay? So automatically you have to remember in some simplifications, multiplication or some adjoint, some determinant, later on you will get these definitions. There you may get simplifications I square 1 upon I, that means 1 by I, etc. I square value minus 1. Okay. If necessary, these are also useful. I cube is equal to minus I power 4 is equal to 1, etc. 1 upon I is equal to minus I. These may be useful in coming topics, that is simplifications purpose. So this is a complex matrix. Maybe square matrix or rectangular matrix, anything. The next one. A power t or a dash is called transpose of a matrix A, which is obtained by interchanging rows and columns. So, when we require transpose of a matrix A, in the given matrix, interchange rows and columns, which is the required A transpose or A power T or A dash. Okay. Example. A is equal to 1, minus 2, 3, 0, 1, 4. This is 2 cross 3. From this, A transpose is equal to 1, 0, minus 2, 1, 3, 4. This is 3 cross 2. So when A is M cross N matrix, its transpose is N cross M. That is interchanging rows and columns. Next. A bar is called the conjugate of matrix A. So that means every element is replaced by its conjugate. Every element is replaced by its conjugate. Then the matrix so obtained is called conjugate of the given matrix generated by A bar. Okay. And A power theta is equal to A conjugate transpose or A transpose then conjugate. Both are giving the same answer. Is called conjugate transpose of matrix A. Some people called as transpose conjugate of matrix A. Both are same. Okay. Example. A is equal to 2 minus 3i 0 1 plus I minus I, which is a 2 cross 2 square matrix. At least one element is complex number A bar. So what is the conjugate of element is obtained by change of I symbol. So in our complex numbers of our childhood class, 11th class, x plus iy is a given complex number. What is its conjugate? X minus iy. That means change the symbol of I. Plus I becomes minus I becomes plus I. So 2 minus 3i conjugate is 2 plus 3i. 0 conjugate. Real number. The conjugate of real number is itself. Real number has no conjugate. Okay? That means because real number has no imaginary part. That's why. 1 plus I conjugate is 1 minus I. Minus I conjugate is I. 2 cross 2. Implies A power theta is equal to A conjugate and then transpose. So this is A conjugate. You know how to find transpose. Interchanging rows and columns. 2 plus 3i, 1 minus I, 0 I, which is again 2 cross 2. This is the way to evaluate or find transpose, conjugate, transpose, conjugate or conjugate transpose. Okay. So if you are interested, here I am writing conjugate of x plus iy, that is, which is a complex number, is x minus iy. So in the given matrix A, every element is replaced by its conjugate. The matrix so obtained is called conjugate of matrix A. Next. The elements A11, A22, so on, AN of a square matrix are called principal diagonal elements or main diagonal elements. So in a square matrix, the line joining the first element of a matrix to the last element of the matrix in a square matrix. So that are called diagonal. Generally in 2D, we have left diagonal and right diagonal. So this left diagonal is considered as principal diagonal elements in a matrix chapter, but not this diagonal. Okay. Other elements are called non-diagonal elements. And other elements means A12, A31, like that. Don't worry about writing, just understand and remember how much you remembered and or having knowledge on these basics, because these are available in our material or any textbook containing matrices chapter. Next, there are 5 special definitions on matrices. I am providing examples because everyone remembered, everyone knows this. Diagonal matrix, second one is scalar matrix, third one is identity matrix, fourth one is upper triangular matrix, fifth one is lower triangular matrix. Okay, see, just now we know diagonal elements and non-diagonal elements. All non-diagonal elements 0 and at least one diagonal element is non-zero. Such a matrix is called diagonal matrix. In a diagonal matrix, if all diagonal elements are same, such a matrix is called scalar matrix. In a scalar matrix, all diagonal elements are equal to number 1. Such a matrix is called identity or unit matrix. If all the elements below the diagonal in a square matrix are 0, such a matrix is called upper triangular matrix. If all the elements above the diagonal of a square matrix are 0, such a matrix is called lower triangular matrix. Easy to remember. Okay, these 5 definitions. Now I am writing directly examples. A is equal to 1, 0, 0, 0, minus 2, 0, 0, 0, 3. This is a simple 3 cross 3 diagonal matrix where highlighted by blue color that below as well as above, which are called non-diagonal elements, must be 0. At least one of the diagonal element is not equal to 0. Is a diagonal matrix. A is equal to 2, 0, 0, 0, 2, 0, 0, 0, 2. This is again 3 cross 3. All the diagonal elements are same. Non-diagonal elements are 0. So this is a simple example of scalar matrix. Next. I1 or I1 cross 1. 1 cross 1 means 1 into 1 matrix. Number of elements in 1 cross 1 is 1. So, in a square matrix, the first element is always a diagonal element. So, one element in a matrix means such element is automatically diagonal element. If all the diagonal elements are 1 and non-diagonal elements 0, such a matrix is called identity or unit matrix. So, this is bracket 1, I2 or I2 cross 2. Some people writing like this. 1, 0, 0, 1. I3 or I3 cross 3 is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. And so on are called identity matrix or unit matrix. Okay. Next. A is equal to 5, 1, 0, 0, minus 2, 3, 0, 0, 6. This is a 3 cross 3 square matrix where the diagonal, that means 5 minus 2, 6 are the diagonal elements. Elements below the diagonal, 0. These are the 3 diagonal elements. Elements below the diagonal are 0. Is an example of an upper triangle matrix. Upper triangular matrix. There are so many examples. Just for remembering or understanding purpose, I am providing simple examples. The last example is A is equal to 1, 0, minus 5, 9. A 2 cross 2 simple example where the elements above the diagonal 0. 1, 9 are the diagonal elements. Above that 0 is a lower triangular matrix. Very, very important. These 5 the definitions. So kindly excuse me. I3, this last element is 1. By overlook, I have done a small mistake. This is 1. And the last definition, trace in the basic level of a square matrix A is denoted by TRA or TRACE and is defined as or given by trace A is equal to sum of the diagonal elements diagonal elements means principal diagonal elements, that is A11, A22, so on, AN. Sum of all diagonal elements is called the trace of a square matrix A denoted by TRA. This is the basics from 10th or 12th, 11th or BTech first year. First level basics. The next level basics on operations, addition of matrices, multiplication of matrices. In multiplication of matrices, how they are asking logical questions previously in gate questions. And remember, some people, this diagonal matrix, or they can also denote it by DIAG, followed by diagonal elements only, 1, -2, 3. Anywhere, in any question, any, book, you have DIAG followed by some elements, which is a diagonal matrix with diagonal elements, because non-diagonal elements is 0. Okay? The next one I am going to start matrix multiplication. Before that, matrix addition. 2 matrices A and B, first of all, same order. Okay. Then matrix addition is denoted by A plus B is possible if they are of same order. And how to simplify that A plus B? Corresponding elements to be added. First element plus first element. Second element plus second element. Correspondingly added. That matrix is called matrix addition A plus B. Okay. So, here M by N is called size or dimension or order of matrix A M cross N. Please remember. Okay. This is not required to discuss, but for some people purpose I am writing, because many of the people remembered order only. The synonyms, other names for order is dimension or size. Next, let A M cross N and B N cross P be 2 matrices. Then, so just see here, number of columns in the matrix A is same as number of rows in the matrix B. Then number 1, matrix multiplication A into B exists and is of order M cross P. That means the middles are cancelled, extremes will obtain. Number 2, this is important point. The number of scalar multiplications in AB is the answer M into N into P. What is scalar multiplication? So let us take two matrices A and B accordingly in that order. Many of you remembered how to multiply. First row elements multiplied correspondingly with the first column elements. Next first row elements correspondingly multiplied by the second column elements, etc. the last column. So these are the procedure for matrix multiplication. When you are taking first row elements multiplied with first column, first element into first element plus second element into second element. So these are called scalar multiplications. That is the inside numbers multiplying, which are called scalar multiplications. Outside matrix multiplication is, this outside multiplication is matrix multiplication. Example. Let A is equal to 1, 0, minus 2, 3, 2, minus 4. This is 2 cross 3. And B is equal to 0, minus 1, minus 5, 2, 6, 3. This is 3 cross 2. Okay. So from this, A into B, matrix multiplication. So these are two equal. Number of columns in A matrix is equal to number of rows in B matrix. So AB, how do you multiply? First row into first column. 1 into 0. This is 1 into 0. This dot is called scalar multiplication. Plus 0 into minus 5. Plus third element into third element. Minus 2 into 6. So this is called sum of the three scalar multiplications, which is the first element in the matrix multiplication AB. Like that. First row into second column elements. 1 into minus 1 plus 0 into 2 plus minus 2 into 3. This is another three scalar multiplications, which is the second element of the matrix AB. Okay. Then bracket closed. Next, third element of matrix AB. That is second row of A multiplied by the first column of B. Second row elements of A multiplied with first column elements of B. That is 3 into 0 plus 2 into minus 5 plus minus 4 into 6, which is the third element of the matrix AB. This is another three scalar multiplications. And second row of A multiplied with the second column of B, which is the last element of the matrix AB. That is 3 into 0 plus 2 into minus 1 plus minus 4 into 3. So finally, this is 2 cross 2. Sum of these elements is a number. Total elements, 4 elements. That is M into P. Okay. So here, M is equal to 2. N is equal to 3. P is equal to 2. Okay. Therefore, the number of scalar multiplications. So each element is 3 scalar multiplications. Total number of elements in AB is 2 cross 2. 2 cross 2 means 4. 4 elements in AB, each element containing 3 multiplications. So total number of scalar multiplications is 4 into 3, 12. And this 12 can be written as 2 into 3 into 2. That means M into N into P. M value 2, N value 3, P value 2. 2 into 3, 6. 6 into 2, 12 multiplication or not. But this is useful in problems recently asked and gave. how they ask. That is the interest. Okay, everyone can do matrix multiplication, but the questions ask generally number of scalar multiplications. And in this, a small result you have to remember, that is from 10th class, 11th class also, associative property, distributive property, commutative property, etc. Okay. A dot B dot C is equal to A dot B dot C. A dot B plus C is equal to A dot B plus A dot C. A dot B not equal to B dot E in general. Okay, these three are called regarding matrix multiplication, which is associative, comma distributive, but not commutative. Implies matrix multiplication is associative, comma distributive, but not commutative. 1 mark, sometimes they ask, they test your knowledge, these childhood class properties. Matrix multiplication is associative or not. That means position is same, first A, second B, third C. But order of the multiplication can change. That is, in the left hand side, first multiply B and C, then pre-multiply by A. In the right hand side, first multiply AB, then post multiplied by C. Both are giving same answer. That means final answer like this. Suppose A, B, C we are multiplying, the final order is 2 cross 2. AB into C is same as A into BC, which is giving 2 cross 2 according to your plan, taking ABC matrices. Okay, distributive means these laws you will get in digitals also. A dot B plus C is equal to A dot B plus A dot D. This is called distributive property. It's a rare case AB is equal to BA. When you are taking two matrices AB, just like this, I have done already AB. Similarly, you do BA. Check that AB is equal to BA or not. Rare case, it is success, AB is equal to BA. Remaining all cases, AB not equal to BA. That is in general, matrix multiplication is not commutative. Okay, 1 more question they can ask. Let us see the previous gate question, how they asked regarding matrix multiplication. So here I have done a small mistake, typing error. Second row multiplied by second column, 3 into minus 1. Okay, this one. 2 into 2 actually, in this case. Three into minus 1 plus 2 into 2 plus minus 4 into 3. This is the last element, sum of 3 scalar multiplications from A into B matrix. have a break. Any doubts? Ask the current topic doubts only.